Hello and welcome to HashiTalks Build. My name is Mo Khan. I am a senior software engineer on the Dependabot team. And today I'd like to tell you a story about a relationship between Dependabot and Terraform and how you can use Dependabot to keep your Terraform dependencies up to date. Quick overview of what I plan to chat about. Chapter one, I'll talk a little bit about the why behind why we have software dependencies. We'll go over what software dependencies are and how you can tell what sorts of changes occurred in a software dependency by discussing versions. And then hopefully I'll provide some practical tips on how you can use Dependabot to keep your Terraform and Golang projects up to date. Let's get started. So like most greenfield projects, pardon me, they typically start with very few, or in some cases, zero dependencies. So I'm just going to create a new Golang project here. It's going to be very simple. All it's going to do is just going to print to standard out. And the idea behind this is it's going to be sort of a sample application that I'll use to kind of simulate a real world app in terms of keeping its dependencies up to date and how we can go about doing that. So in the first version of this application, all we've done is just created a quick hello world app that prints to standard out, as I mentioned, and looks good to me. So let's ship it. Now, as time goes on, uh, we find ourselves wanting more features in our projects. So in this case, I'd like to be able to just print out a little bit more information to the command line or to the terminal. And so I'm going to pull in a package called Logris here. And Logris is going to help us do effectively the same thing it was doing previously, which was to print a hello world message to the terminal. Here I'm pulling in Logris version 1.0.0, and so I want to pin it to like the first one of like a really old version of this Logris package, and I'm going to use it to print hello world to the terminal. And you can see as soon as I added the package, it generated a go.mod file as well as a go.sum file. And as we proceed here, I'm going to give you a little bit more context as to what those two files are and how we can keep them up to date. So there we go. We've updated our project and we've included our first dependency. The go.mod file and go.sum file is now committed in Git, and we're clean. So what exactly did we do here? What is a dependency? And sort of this is what I want to talk about for a moment. So when we're building software projects, um, there are certain types of cross-functional concerns or utilities that are common across projects. Sometimes it's not so common, but there are libraries that specialize in specific needs. And so in our software projects, especially when we get started, um, we can pull in these dependencies in a greenfield style application and look quite youthful. Now, over time, we add our first dependency, and no big deal. We've still got that sort of youthful look, but there's some cost that's associated with pulling in a dependency. So a dependency is really a software package or library that's published by either yourself or someone else. And depending on who or what sort of update mechanisms govern that software project, you are taking on the burden of making sure that you not only receive the updates for that project, but that you stay on top of the health of that project to make sure that if there are problems that arise from usage of that project, you can pull that in. So you pull in your first dependency, and then you pull in maybe a second dependency. And in some cases, when you pull in a second dependency or any dependency, that dependency itself or software library may actually depend on another software library. So when you pull in that one, you're actually pulling in it as well as its dependencies. In some cases, as a project matures, software packages over time will add dependencies on other software projects. So even though at the time that you added the dependency, it may not have had that dependency, but after a little while, it may pull that in. So as you update, you're also pulling in those updates. You're sort of inheriting the decisions or yeah, inheriting the decisions made from those software projects as your project grows. Now, over time, those dependencies may actually pull in more peer dependencies that hopefully are under some form of scrutiny and review. At times, you may have dependencies that uh, actually conflict with one another because of version constraint conflicts, which making it difficult to update. And sometimes you'll see, or you may not see, dependencies getting hijacked or pulling in things that you didn't actually realize were getting pulled in and sort of was backdooring into your systems without you understanding it. If you've worked on software projects like myself, you might look at your manifest files and ask yourselves, why do we have two different dependencies that sort of look the same or do the same thing or provide the same value? In older projects, you might find dependencies that have been there for so long, you're not even sure what it does or how it works or if it's still necessary, but it's still within your realm of responsibility. And after a while, once you've accumulated enough dependencies, it can feel like you're spending more time just combating those dependencies rather than actually deriving value from them, whether it's from continuously keeping them up to date or dealing with defects or dealing with conflicts. You may find yourself having to fork those dependencies and maintain your own copy of them just so you can make progress. And then it can get confusing as to which version of this package are we using, and is it our version or their version? And you may even find yourself in some cases like with dependencies which don't even make any sense. If you're, for example, being in a web project that pulls in dependencies that write ANSI character codes for terminals, let's say, for example. So software projects um, can leave you feeling rather confused and just absolutely unsure of like how to proceed next. So let's take a look at an example software project that has been around for a little while. It's still a fairly new project, but it's been long enough that it's actually accumulated, I think it's something in the neighborhood of 400 plus dependencies. And so it's an example of a go.sum file for the GitHub CLI project. And as you can see, there's several different dependencies and there's different versions of that dependency. And over time, it can be quite difficult to maintain a catalog of what's in your projects or what they do. The cryptic names associated with some of those dependencies can also make it difficult to just glean the intent or the value that's derived from those dependencies, making it sort of difficult to understand what is in your software supply chain for your product. So, um, one thing to keep in mind, or another thing to keep in mind, is that dependencies have needs. So when you first take on the dependency, which may have seemed like a good idea because it was adding some sort of value to your life or to your project, you're also indirectly taking on the responsibilities and obligations of that dependency. Dependencies can also be vulnerable, meaning they're subject to exploit. So if you have vulnerabilities in those software dependencies that you depend on that are unpatched, it exposes you and your projects to those same exploits. So keeping your dependencies up to date and keeping a good sort of audit trail on the history of those changes is important. So let's go back to that same project earlier, and I wanna level it up a little bit. This time, I would like to be able to print out a timestamp to the output. So when we print "Hello World," I'd like to be able to include a timestamp, but I wanna fake out the timestamp to something in the past, let's say a year ago from now. And I'm also gonna just emit the log format as a JSON format. So each line will be a single line of JSON. And so I found like in a newer version of this log roast gem, it offers this thing called with time. So you can actually pass in the time to print in the log line. And I'm just going to take the current timestamp and just subtract like a year from it, and that's what I'm going to print in the actual log line. Now, I don't know why anyone would do this. This is a really uh, made up example. Uh, but here we'll see that I can't actually use that with time function because it's not available in the version of that particular package that I was using. So I'm going to go ahead and just pull in the updated version of that package, version 1.0.6, that introduces that new feature, and rerun the program. And as we can see, it is now printing timestamps from a year ago. By doing this, I've also included additional dependencies in the go.sum and go.mod file. And that's because the newer version of that logres package actually pulled in some more dependencies for us. So that's fine, no big deal. Go ahead and I'll commit that to my project. So we started with fumped.println, then we added logres, and then we updated logres. We can include a timestamp. So my project is, you know, getting better. It's adding more features. We can now print hello world in a JSON format with a timestamp, but we can fake out the timestamp to a year ago. So success, yes, this is fantastic. Now, this is like one example of like why you might need to update your software dependencies, but there's many different reasons why you might want to update your software. And some of those reasons might include uh, new features that are exposed in those libraries. Sometimes there's just bugs in those libraries that need to be corrected. And every once in a while, like a new major version of that library might be pushed out, which might include some breaking changes. So those are sort of the types of changes you have to monitor and keep track of. The more you fall behind those sort of upgrade paths, the harder it becomes to upgrade. So there is this sort of need for you to be aware of new versions of those software dependencies in your projects so that you can stay on top of the latest updates without falling too far behind for some of these reasons. Now, there was something sort of well known in industry now, semantic versioning, which is a way to indicate the reason that a particular software package has changed using version numbers. So in the semantic versioning scheme, it is made up of 3 digits delimited by a dot. In its most basic form, there are some extensions to this for special cases, but in its basic form, there's 3 digits, and the first digit indicates the major version number. And so anytime that this major version number changes, it can represent an API incompatible change, or it can introduce breaking changes. And so what that usually means for you, the software project maintainer, is that it usually means some work for you in order to do the upgrades. You may have to change configuration or the way you use the library because APIs might have been deprecated, but it has some impact to you that is not as simple as just upgrading without any code change. There's usually some work or effort involved. And there's usually some benefit too for upgrading to a major version. It might be a significant number of new features or performance improvements or just internal refactorings to minimize the client API for other reasons. But this is sort of like the more riskier change. So whenever you see that major number change, that's something to consider. The second number in the semantic versioning scheme is the minor number. And in its essence, it represents really a new feature or something that's changed that you might want to take advantage of. Now, this is also meant to indicate that it's a backwards compatible change, which means you should be able to just update your projects to this new version. So let's say that number went from 0 to 1. You should be able to pull in that change without having to deal with any sort of code changes or breaking changes. So this should be a safe upgrade path that allows you to add or gain more functionality in your programs because it's being offered from the library. And the final number in the semantic versioning scheme is the patch number, which usually indicates that a bug fix has been released. So when that number increments or goes up, it means that something was broken and now it's fixed. And so this is something that you typically want to pull in more often because this number is probably going to be the one that changes the most frequently in your software dependencies. And you'll probably want to update those to receive the fixes that are included with those. And this is also meant to be done in a backwards compatible way, so it shouldn't break API. It shouldn't require you much effort. It should be like the simplest way or the simplest upgrade for you. in terms of the semantic versioning upgrades. Now, let's go back to a couple of other different ways to keep track of your software projects. So when you have a software project, there's two kind of questions that you may be asking yourself in terms of like what software dependencies do I have in my project? The first one is what are the eligible versions that I am comfortable with in terms of upgrading my software dependencies? And the second question might be what is the current list of versions that we're actually using in our software development packages or dependencies? So in the case of go.mod or Go programs, using Go modules, the go.mod file is more or less like the description of the versions of dependencies that you're comfortable with using in your project that you want to use. Now, Go itself doesn't seem to have the same level of flexibility in terms of the different version constraint syntax. It's done a little bit differently than on some of the other package ecosystems, but in this case, you can see that our program is clearly dependent on three specific packages. The one that we pulled in exclusively was that logres gem, and we said we're directly dependent on version 1.0.6. That / indirect, I think, needs to be fixed. Um, and so this is meant to be like a developer-facing file that you potentially could update. In this case, there's tooling that allows you to update it as well. But yeah, this is the file that's meant for developers. So say these are the things that I sort of depend on directly. And then anything with those comments is indirect. Now, in a Go modules project, there's also the go.sum file. So the go.sum file is like the equivalent of a lock file. And this answers the question of what versions of dependencies are we currently dependent on in this software project. So you'll see each line in the go.sum file is delimited by a space. And so there's three sections on each line. The first section is the name of the package. The second section is the explicit version of that package. And the third section describes a digest so that we can tell whether or not we've pulled in the appropriate package or if there's any sort of tampering or spoofing happening in between. The H1 key, I believe, sort of denotes a specific type of hashing algorithm. And so we can confirm the digest that way. So in essence, the thing that's most important about the lock file is the name, the version, and the source. And in this case, in Golang, in the Go module system, we can see the source is actually part of the name itself. It's sort of like the fully qualified name for that package. And this is also like meant for machines, right? This is for computer programs to generate and to use. It's not really something that you would modify by hand. It's not meant for developers to use directly. Computing and verifying those hashes isn't something that's trivial to do by hand. All right, now let's switch a little bit to a Terraform project. In this case, I've got a Terraform project with a main.tf file. And in this main.tf file, dependent on two things. One is a Terraform provider. That's the HashiCorp AWS Terraform provider. And the second is a Terraform module. So if we zero in on the Terraform provider for a moment, we can see there's two things that we describe in terms of what we want as developers. So we want to use the HashiCorp AWS Terraform provider. We don't explicitly specify the registry to pull from, so the default registry is in use here. So that should be pulled from registry.terraform.io, if I remember correctly. And the second thing we specify is a version constraint. So the version constraint here, we're using a tilde bracket to specify a pessimistic version constraint to say that we're willing to pull in any sort of updates to this Terraform provider as long as they don't include any breaking changes. So anything above 3.0 all the way up to but not including 4.0. And this means we'll get any new feature updates, being the major updates in the semantic version number, as well as any bug fixes and patches. And so that version constraint is great. It's open enough that it allows us to pull in safe changes, but it's restrictive enough that we don't pull in major changes that could potentially cause us
I'm having trouble hearing you.
us to need to spend some time to go through the upgrade path. Now, in the second section here at the bottom, where we describe, or where we're actually dependent on a Terraform module, the source, similar to the Terraform provider, in this case, we're specifying a fully qualified name, which includes the registry, which is app.terraform.io, a organization namespace, and then the actual name of the module, the S3 web app slash AWS. And same thing, we provide another pessimistic version constraints to say that anything within the 1.x.y range is just fine. Pull those in automatically. And this is nice because having those constraints allows the underlying tooling to determine what versions are eligible for this particular project. So, so again, we've got two pieces. We've got the manifest files. So in the Golang project, it was the go.mod, and then in the Terraform project, it's the equivalent of like a main.terraform or main.tf, where developers could say, here's what I need, the dependency itself, and here's what range of versions I'm comfortable with. Um, and then on the other side is we've got the machine friendly file, which specifies the exact versions of those dependencies. In this case, that's done through the Terraform lock file. And we can see here that it provides us the fully qualified name of that provider, registry.terraform.io / HashiCorp / AWS. We can see the fixed version that was resolved to satisfy the constraint. So in this case, the fixed version is 3.47.0. And that was the version that was resolved at the time that we did the Terraform init, or for the first time, or Terraform init-upgrade, because that was the newest version available at that time that could satisfy the constraint of tilde-waka 3.0. Now, if we were to go to this project today, if we were to go into it and write Terraform init-upgrade, it would probably find a newer version up on the registry. And it's likely that the newer version would still satisfy this constraint of being within the 3.x.y range. And so we'd be able to update. And the hashes you can see here are very similar to the hashes that we saw in that go.sum file, because the underlying mechanisms for all this is still going. Now, I've got some good news because like keeping all these things up to date takes a lot of work. You've got to stay on top of all the dependencies that your project depends on. You've got to stay on top of all the reasons that those dependencies are changing, and so to make sure that you're actually pulling in updates for the right reasons. And so this is where something like Dependabot comes into play, because Dependabot can keep your dependencies up to date for you automatically. And it can also do that by providing you with enough metadata and information for you to make a good decision without you having to go trace down all the newest versions of all packages and all the reasons why they've changed. So let me just get into a quick demo here. Let's go through and take our same project that we've been working on so far this whole time. And let's figure out, let me just show you how you can configure it to enable Dependabot. So the first thing you'll need to do is you'll need to add a GitHub / dependabot.yaml file. And this YAML file is a configuration file that tells Dependabot how you'd like to do these updates. So you can have multiple update configurations for different ecosystems. So for projects that are monorepos, you can specify a different root path for each of the different projects in your Git repo. Slash is sort of like denoted as the root of the Git file system. And then you can specify the update interval. So once you've specified those sort of bare minimum things, you can commit that and push that up to GitHub. And once that dependabot.yaml file is pushed up to GitHub, Dependabot behind the scenes will detect that file and attempt to satisfy whatever is configured there. So here we can see that we've configured a Go mod package ecosystem update configuration. We've specified the root directory for this project to be the root of the Git directory, but it could also be a subdirectory within this project. And we specified a scheduled interval of daily. So which means like on a daily basis, this will attempt to check for any updates in this project and Dependabot will then submit a pull request. So when Dependabot kicks in, it will go and try to figure out if there's a newer version of dependencies that are in your project. In this case, we can see that the latest version of the logris package is 1.8.1. So Dependabot's providing us with some information as well as a pull request with the appropriate changes for us to decide if we want to upgrade to 1.8.1. Now, this project is using semantic versioning. Upgrading from 1.0.6 to 1.8.1 should be a backwards compatible change. So for the most part, nothing, no additional like code changes should need to be made in order for this upgrade to work. However, it is good to have like tests to verify that. And since this is being submitted as a pull request, this will trigger your checks on your repo to make sure that everything is working as expected. But this is fantastic. So we can see the upgrade path from 1.0.6. We can see all the release notes. We can see the list of commits between the two different versions, and this helps us to decide whether or not this is a safe change for us to go forward with. Now, if you're curious to see like how Dependabots, you can go ahead and look at the update logs by clicking on Insights, go to Dependency Graph, click on Dependabot, and you can see like the update logs for each update job that's configured in the repo. So if something's not working correctly, this is probably the place you'll want to go. And if we scroll down a little bit, we can see where Dependabot detects that the latest version is 1.8.1 and where it attempts to complete the upgrade from 1.0.6 to 1.8.1. Now, this also works for Terraform projects. So this is a different Terraform project. This is actually a project with the several different projects in the source directory. So if we take a look at here, there's a Golang project in the root, there's a bundler project, a Python poetry, plus this Terraform project. This same Terraform project includes the same Terraform provider as well as a module that I had shown in a previous slide. And this is configured to also just check for updates against the Terraform, in this case, a Terraform private registry, hitting app.terraform.io. So once it's detecting, yeah, we can see that it's detecting like a brand new update. So it's suggesting that we upgrade from 3.49.0 to 3.50.0. And ta-da, we've got all the info that we sort of need to make that decision. Now, if the project's following semantic versioning, this should be a backwards compatible change, and we should be able to go ahead and merge that. So that kind of in a nutshell is why you can still feel youthful and young, like that same freedom you had with like a greenfield project with your older projects. So if you've got dependencies, why not Dependabot? If you're looking to get started on Dependabot, or if you have questions, a great resource to look at is docs.github.com. Here you can see a list of all the different package ecosystems that we support, and there's quite a few. We're constantly trying to expand support. There's example configurations on this page, and hopefully a lot of answers for some of the common questions that you might have. And so in summary, Dependabot updates your dependencies for you so that you can focus on building new features and functionality, but keeping your software as up to date as you're comfortable with. And that's it for me. Yeah, so if you've got any questions about Dependabot, a great place to look is github.com/Dependabot. And if you'd like to find me online, you can find me at most places on the internet as Extra Large Mocha. Thanks.